You create the world of the dream. We bring the subject into that dream with their subconscious.
How could I ever acquire enough detail to make them think that it's reality?
Well, dreams, they feel real while we're in them, right? It's only when we wake up that we realize something was actually strange. Let me ask you a question. You never really remember the beginning of a dream, do you? You always wind up right in the middle of what's going on.
I guess, yeah.
So how did we end up here?
Well, we just came from the,
Think about it, Ariadne. How did you get here? Where are you right now?
We're dreaming?
You're actually in the middle of the workshop.
Now, we all love the movie Inception, where people were able to plant ideas into the heads of others. And we all thought that it was a great science fiction movie. But what if I were to tell you that it is possible? That scientists have developed a way to tap into the brains of others and create false memories that are just as authentic as the real ones. The underlying concept that scientists base their method on is referred to as engram. Engram is a hypothetical change in a neural tissue postulated in order to account for the persistence of memory. It was believed that engrams existed in neural networks spread across the brain, but a series of studies in mice have shown that memories can be placed in particular neurons. If those neurons were then removed or inactivated, the memories would vanish, and if the neurons were reactivated, memories would reappear. Current technology doesn't allow memories to be completely eliminated without neuronal damage, but simply manipulated. In the mice studies, the amygdala region of the brain that stores memories related to fear and other unpleasant stimuli was targeted. The mice had learned to associate a sound with an unpleasant electric shock stimulus. The researchers then showed that immediately after recall of the false memory, levels of neural activity were also elevated in the amygdala, a fear center in the brain that receives memory information from the hippocampus, just as they are when the mice recalled a genuine memory. By inactivating the particular neurons that were active during its experience, the mice no longer responded to the sound as indicated of an upcoming shock. This suggests that it didn't remember the experience it originally had. It can't be said for certain if the mice didn't remember what the sound meant, or if it was just not reacting to it. Optogenetics is the name of the technology that allows scientists to control brain activity by shining light on the neurons. The neurons have been genetically engineered to include the light-sensitive proteins from algae that stimulate electrical signals in the cell due to their sensitivity to blue light. Light-sensitive proteins sensitive to orange light are also present to suppress the electrical signals. A newer protein called JAWS has been discovered that will allow a larger volume of tissues to be affected non-invasively with these proteins. Opsins can be seen affecting the mouse by stimulating its urges to eat with the blue light and then suppressing it with the orange light. A newer protein called JAWS has been discovered that will allow a larger volume of tissues to be affected non-invasively and without the need to implant a light source in the brain. This technology is currently being studied on mice, but looks promising for treating many human diseases such as blindness. In this case, there were two groups of mice, the control group of blind mice and the blind mice treated with optogenetics. They had to swim out of a small maze with the exit indicated by light. The blind mice with no treatment had to feel their way out, but the ones with treatment responded to the light and escaped rather quickly. In the U.S., about 1 in 4,000 people have lost their sight due to retinitis pigmentosa, where the light-sensitive cells in the retina are destroyed. Perhaps this could be the future for treatment of this specific case of blindness. Since the 1990s, when DNA testing was first introduced, Innocence Project researchers have reported that 73% of the 239 convictions overturned through DNA testing occurred because eyewitness testimony was false due to the result of false recollections. Unlike procedures that could be done with mice, many researchers have only demonstrated the occurrence of false memories in human subjects through suggestion and digitally altered photographs, which already had severe implications in society, as demonstrated by the Innocence Project. Clearly, creating false memories must be no small matter. The further development of this technology for use on humans could be revolutionary and also used for evil if it falls into the wrong hands, like if criminals decide to just brainwash the minds of any witnesses to a crime. This technology could also be used for good by changing the memories of post-traumatic stress patients to a pleasant one. This newfound knowledge on memory manipulation may have many consequences in the future, but will probably be kept simple for a long time until the potential consequences of further researching this technology are fully assessed and understood.